Today I've got 5 Unity tips for you. They'll save you time, clean up your code, and make your workflow a lot more easier. Let's start. And to explain tip number 1, we have a player here with the player controller script. And in the script, we have a public float speed and a serialized field private rigid body RB. The tip is pretty simple. This is editor only. That is to use the reset function. If you type reset, Visual Studio suggests the reset function, press enter. There we go. This is a built-in function inside of Mono behavior that lets you reset your variables directly in the inspector. Inside this function, we can set speed equals 10f and then save. If you go back and inside player controller, we can now click on these 3 dots and press reset. And this is going to reset our variables back to the value that we want. Which means whenever we press reset, whatever code that we write inside this function will be executed, which is great because now we can say RB equals get component rigid body. And if you go back to the player, click on reset, it will automatically assign references, which means we don't have to drag and drop these things again. When and why is this useful? This is useful if you're working on a big team. The second time is when you're creating modular assets. If you're creating a package, you can create a reset function inside every single script, which works only in the editor. Now you have a function, built-in function to manually reset variables, and you can use it in your own logic whenever you want. Okay, it is great. So start using reset functions. But the second step is really going to be useful. In this example, we have a bunch of enemies and they have the same enemy script, which contains health equals 100. If we go to code, giving respect to the first step of the video, I already added a reset function. Now let's say there is a function called randomize health in which we randomize the health of the enemy. If I want to call this function inside the editor at any time, I can actually create an attribute above this function called context menu and then give a parenthesis, and inside double quotes you can give it a name. Let's call it randomize health, and that is it. If we save, go back, let me actually select all of my enemies, hit reset so that everything is set back to 100. Now I can just simply select enemy 1, 2, 4 and 5 and then go to the enemy script. I can click on the 3 dots and press randomize health. Now you can see the values are different. Enemy 1 is 64, enemy 2 is 69, enemy 4 is 196, which means whatever code is inside this function will be executed. This is great. Now this can be used in a bigger scale. Let's say we have a function called debug enemy death. We don't have to spend a lot of time to get to the point that an enemy dies. Instead, we can simply, have a function called debug enemy death and simply add a context menu to it. So context menu, let's call this debug enemy death. And there we go. I'm going to click on enemy 4 and enemy 7 this time. And then I'm going to debug their death. And on the console, you can see enemy 4 is dead, enemy 7 is dead, which is great. You can also make it so that the enemies are spawned at random enemy spawn positions inside the editor. You can do whatever you want. I have a complete dedicated video on context menus if you'd prefer. You can see it on the top right here, and the link is in the description. The third tip is a workflow related tip, and that is to use the keyboard shortcut Shift plus space. You can press Shift and space to maximize the current window. In this case, it is the scene view. Let's say you're working on a terrain. Shift space and then I make them changes. Shift space back. Then I go click on the inspector and then change the properties here. Then I go back, shift space, change some things here. You can make it a part of your workflow. But the cool thing is you can actually pop out a window from your Unity editor, and this will not be included in the shift space thing. Now, in this example, if I want the inspector as separate, I can keep the inspector here and then go back to the scene view, press shift space, click on them. I still have the inspector. This is great, right? This is super cool to work with because I now have the inspector, and I can still work on my scene, do whatever that I want to do. This is especially great when you have terrain. If you want to paint on the terrain and stuff like that, you can keep your inspector here, or you can just drag this window into your second monitor. I have a second monitor here. That's where I usually work. But you can do that, and that is insane. This is going to speed up your workflow a lot. This is especially useful if you're working on laptops or smaller screens. Okay, cool. Now here's a tip for anyone who's ever had a mysterious bug. Because one script runs before another, instead of fiddling in the project settings, like you can go to edit, project settings, and then script execution order to change the order in which your scripts are run, you can use the script execution order, which is a recommended way if you are working in a big company. If you are indie, and if you're someone who's like more into programming side of things, I have a separate solution that is also equally valid. It has its own cons, but it could be great if you're into such things. And that is to set the execution order via code. In this example, I have 3 game objects called early, late, and normal. Early contains a script early init, late contains a script called late init, normal contains a script called normal init. I'll show you the scripts. This is normal init, just an awake function which prints normal init awake. Inside early init, we have the same class, we have the same awake function, but we have a default execution order attribute at the top, and then we can specify an integer. This is the same as the integers in the script execution order itself, and now you can directly specify it through code. So for the early init, I've specified a value -100, which is less than 0. And for late init, I've given an execution order +100, which is greater than 0. Now what this does is negative numbers runs earlier and positive numbers run later. So the first execution will be early init, then it will run normal init, and then it will run late init. Okay, we can confirm that by just hitting play. And in the console, you can see that early init is called first, normal int is called at normal awake, and late init is called at the end, which is great. This helps avoid race conditions. So what you can do is make sure that all of your initializations are done early in a separate external script with an execution order which is less than 0, and then you run the code. Yeah, that's it. Let's say you have assets to load, resources to load at runtime. So you need to make sure that early init happens first. And you can do that with default execution order. It's a simple attribute, but once you get used to it, it's very powerful. The cons of this is that you are now using magic numbers in code, which means once your project gets big, it's a lot more complicated to manage all of these things. But the upside is you get to avoid race conditions through code, and it will be a part of your version control, like Git. Okay, this will be baked into your code. You'll be able to read it from the outside to figure things out, but it is great to know that these things exist. Okay, and finally, this is one of my favorites and something that I've learned only recently, and that is to serialize auto properties. And what the heck do I mean by that? We have a game object for player stats. Typically, when we are noobs, this is how we create player stats. Okay, public int health, public int mana, public int stamina. This is how we usually start. This is the noob way of doing things. An improved version of this is using something called properties. Okay, you have a serialized field, private int health, which is a field, and for that field we created a property here by saying public int health, a lambda operator health. You can also use private get and set. That's completely up to you. You can do that. This is a much more improved way compared to the other one, because this value is private and we are not directly changing the health. Other classes can only set health by setting this health. You can also use scriptable objects, which is a better way to use improved player stats, but this is just for example. And finally, the Ultra Boss Pro Coder version of player stats looks like this. It's not complete. We can use properties. We can create a public integer health, and then we can give it a get, but we can also give it a private set, meaning any external class can still get this value, meaning access this health variable, but this property can only be set privately. I hope this makes sense, because external classes can no longer set this. If there is an enemy cannot access the health of the player. Okay? But enemy can call a take damage function, which is public, which in turn changes the value of health. I hope this makes sense. The problem with this is that you don't have access to this in the editor. Okay? This is because C# compiles it into something called a hidden backing field and a getter and a setter method. And Unity doesn't know how to serialize it. The tip is to actually use properties like these for your variables, okay? And then use the attribute called field, and then we can give it a colon. We are actually forcing Unity to convert this into a field, and then we can specify serialize field. That is it. And I can do the same for mana and then stamina. Let me clean it up. There we go. Field, serialize field allows you to serialize a property that has private set in the Unity inspector. Field is called a targeted attribute specifier. I am learning this just now. I've just Googled it up. And this applies whatever attribute is coming next to this backing field that I mentioned earlier. Okay, that's what it does. Now, if you go back, you can see we have the option to change the health, mana, and stamina, but they cannot be set via an external script. In this sort of approach, there is no control over data. You can actually set health to -99 and it will break the game. Now, in the improved version, we actually make sure that we use a separate function called take damage. This actually does the logic. So in a way, this actually has control over data in the improved player stats itself. We also use a function to do the things for us, which is great. It's also easier to debug because now when there is a value that is changed, you know that it is being set privately, which means you only need to look inside this class. Okay, you don't have to bother if any other external script is using the health variable inside the script because it is no longer publicly set. This actually promotes encapsulation. Now, when it comes to multiplayer games, a hacker cannot simply break an encapsulation. That's not how it works. But a thing to note when you're working with multiplayer games is to make sure that you design your game so that the server is responsible to change public stats. Currently, this is completely client side, meaning cheaters can actually change the values through their own external stuff and give the player infinite health. Hey, that's completely possible if you keep your code on client side. You need to make sure that the server is trusted to change these values. And typically different networking engines have their own way of handling things. Okay, that's just a tip. This is extremely secure, even though we're using public. Okay, don't worry about this too much. And that is the tip, to use properties with private set and use the field serialize field attribute. So I hope this video was useful. Let me know in the comments below if it isn't. If you got your own Unity tips, please do share it below so that I can make a video out of them. And as always, take care. I love you. Bye.